Here are the answers for the Day 3 bell work. Balance each chemical equation. So question A, first locate the arrow right here, which separates the reactants from the products. Then look on the reactant side at any one of the elements you want to start. I'm going to look at the N first, the nitrogen. There is one N written here. Now I'm going to look on the other side of the arrow, and I observe there are two N's. These need to be equal, so on the left side in front, I'm going to write a coefficient of 2. This is how I end up with 2 nitrogen atoms on this side to correspond to the fact that there are 2 nitrogen atoms on the right side. Now let's look at the letter H, hydrogen. On the left side of the arrow, the number in front gets multiplied to the subscript to tell us that there are 6 hydrogen atoms. If we have 2 H3s, then we have an H3 and another H3. That's 6 atoms. On the right side, we need to put a 3 in this position because 3 times 2 would be 6 hydrogen atoms. 3 H2s mean H2, H2, H2. That's 6 of them. So by putting a 2 here and putting a 3 here, that is called balancing the equation. Question B, locate the arrow so you can tell the left side from the right side. Then choose any element you want to begin with. It really does not matter. I'm going to look at the Zn, zinc. There is one zinc atom here. And now I'll go over to the other side. There is one zinc. Those balance. Now I'm going to look at the capital S, the sulfur. That's separate from this S because when I get to this S, I'm grouping it with the O4 and I'm considering this to be SO4, sulfate. So this S is the one I'm looking at right now. This is sulfide. This is a single sulfur atom right here. Okay, on the other side, this is a single sulfur. Those match. Now I'm going to look at the H, hydrogen. There are 2 of them here. On the right side of the arrow, how many hydrogens? 2. Then I'm going to look at sulfate. So I'm considering this together and saying that this is a single SO4, a single sulfate. On the other side of the arrow, this is also a single sulfate. Everything balances right now. We do not need to put any coefficient numbers in. Just having a 1, a 1, a 1, and a 1 is already balanced. Question C, here's the arrow. Okay, on the left side, I'm going to look at the Na first. There are 2 NAs here. On the right side of the arrow, there's only 1. So we need to put a coefficient of 2 in front. That's how you make this have 2 sodium atoms. Now I'm going to look at the O. There is 1 O here and 1 O here. That is a total of 2 oxygen atoms on the left side. How many oxygens are on this side? The 2 in front means there are 2 O's. So those match. Finally, let's look at the hydrogen. There are 2 H's here, and on the other side, because of the 2 in front, that's also 2 hydrogens. So this is balanced simply by writing the 2 in this position. Question D. Here's the arrow which separates the sides. This is a hydrocarbon combustion reaction. It's got the hydrocarbon, it's adding oxygen, the product is the carbon dioxide and water. So when you have this reaction, my suggestion is you balance the carbons first. This has 6 carbons. So on the other side, for this to have 6 carbons, we need to put a 6 in front. Then balance the hydrogens. This has 12 hydrogens. On the other side, for this to end up with 12 hydrogens, what coefficient is needed? It has to be a 6, because 6 times 2 is 12 hydrogens. Then we're going to figure out what goes in front of the oxygen. On the right side, how many oxygens are there? There's 6 times 2, 12 oxygens, plus, and then over here there's 6 in front of this O, so that's 6 more oxygens. That's 18 oxygens on the right side. So on the left side, we need 18 oxygens. Well, please notice there's already 6 of them here. So 6 plus 12 is 18. This portion needs to be 12 oxygens. What number needs to go in front? It needs to be a 6, because 6 times 2 is 12. So this 6 O's and this 12 O's is the 18 O's that are needed to balance. This equation is balanced by filling in a 6 here, a 6 here, and a 6 here.